Hey Bulldogs, Chris Bryant, CCNA number 12933 here, and in today's Cisco CCNA tutorial and video practice exam combination, we're going to be taking on distance vector protocol behavior and static routes. We're going to be presenting you with 5 questions today, most of them multiple choice, and of course our multiple choice questions are always the dreaded choose all that apply when it comes to the right answers. They're not always the most fun in practice, but it's good practice for the exam as well. Also, in today's exam, we're going to have a tutorial or two built in as well. So we're going to go through the questions pretty quickly. So if you need to pause the video for a moment or two while you think about your answer, feel free to do so. And let's jump right into question 1. Which of these routing protocols uses broadcasts to transmit routing updates? We'll head over to question 2. When using the IP route command to create static routes, which of these 4 are acceptable options? Sometimes we can use an IP address and sometimes we can use the name of an interface, but we need to know which is going to belong to the next hop and which is going to belong to the local router. Let's go ahead and head for the next question. Is it possible, and legal of course, to create a static route to the address 0000? Which statement best describes that? Next question, identify the advantages of using static routes. We spend a lot of time discussing dynamic routing protocols, but static routes are important too. Which one of these are advantages? And then finally, a short answer question for you. What network rule is described by this statement? A route cannot be advertised out the same interface upon which the advertisement for that route was originally received. And that's a distance vector routing protocol rule. Also, for extra credit, tell me why that's true. What does this help do? Let's go back to the questions then, and let's hit question number 1. The only routing protocol on this list that uses a broadcast is RIP version 1. RIP version 2, OSPF, and EIGRP all use multicasts to transmit their routing updates. With question 2, sorry about the slide there, when we use the IP route command to create a static route, you can either indicate the IP address of the next hop router or the name of the local router's exit interface. And I'm going to bring the live equipment up here and we'll take a look actually at the syntax of the static route command, IP route that is, and also we'll see what happens when we try to create a static route that uses the local router's IP address as the next hop. And we're going to be using the serial 0 interface here, and as you can see from the output of show interface serial 0, the IP address of this particular interface is 172.12.123.1. So let's just say that we're going to use the IP route command here, and we'll look at the syntax step by step going left to right. Profile and VRF for the CCNA, I would not concern myself with those options, but destination prefix we definitely want to concern ourselves with. And let's just say we're making it a destination route, destination of that network. You're always going to put a prefix mask in your IP route commands. You don't use wildcard masks here. Got to watch that on your exam as well. Now we can specify either the forwarding router's address, as iOS help tells us, or one of these local interfaces. And what happens then if we attempt to set it to the local router's IP address? We're going to hit it right here. We hit enter, and we actually get a little message. I love the paren here. I love it's almost like it's whispering to you. You get a message, invalid next hop IP address, or just invalid next hop address, and then it mentions, oh yeah, by the way, it's this router. It's real easy to do, but as you see, the router will not let you do that. But of course, that's one of those behaviors we have to know about for our CCNA exam as well. So again, when you're using the IP route command, if you're specifying an IP address, it's going to be the IP address of the next hop router. If you choose the option about naming an interface, you are naming the local router's exit interface. Is it legal and possible to create a static route to the address 0000? Got a good way we can find out. We're going to try to write one right here. So let me just backspace over that. We'll just go over the whole thing and go to another line. And if we put IP route, and again we put our destination prefix here, And then we put a destination mask here. Then we could either put the forwarding IP address, the forwarding router's address, or the local exit interface. And we could use that, serial 0. And that would be it. That is a legal command, as you can see. And what you've just done is actually created a default static route. And here in the routing table, what you'll see is S asterisk, and that indicates a default static route. So that is the key right there. You can indeed create a static routing to the address 0000. Just make sure you follow it with a network mask of all zeros, and then you have created what we call a default static route. The advantages of using static routes: highly scalable solution, no. It's definitely not a scalable solution, because the larger your network gets, the more static routes that you and I as the network admins have to continually go around and keep adding static routes. It is not considered a scalable solution. You will have less packet overhead on your network because all of our routing protocols have some kind of overhead. Some send full routing tables in their routing updates. Some send hello packets, so there's some kind of overhead. Static routes don't have any, so yes, less packet overhead is an advantage of a static route. Updates use multicast rather than broadcast. That's really not true at all, because it's not going to use either one. It is static. And you can use static routes to replace multiple dynamic routes, and that comes in handy particularly on a spoke router in a hub and spoke configuration, because if you're looking at a situation where you got a spoke router and everything it sends out is going to go to the hub, you only need really that one default static route saying, I don't care where the data is destined to, just send it to this next hop IP address. So the true statements here are B and D. And what network rule is described by the following: this is split horizon, and it is a default distance vector behavior. It's not a default link state behavior, but it is a default distance vector behavior. And the reason we run split horizon is to prevent routing loops from forming. Remember, STP prevents switching loops, and split horizon and route poisoning, among other behaviors, help to prevent routing loops. Hope you enjoyed today's tutorial. We've got hundreds more on the way, and literally over 100 on our YouTube channel alone and the Bulldog blog. So make sure to check us out there. Thanks again for your time. I'm Chris Bryant, CCIE number 12933.